about to get the eye roll of all eye rolls. But hear me out, Kmart. Hear me out. If Andy Dalton gets hurt or struggles early in this game on Sunday night, the quarterback they should go to is Nick Foles. He's on the roster. Here's my question. Marcus, here's the question. Is Justin Fields ready to play or not? Because if Justin Fields is ready to play, he should be your starting quarterback. And if he's not, then it is because he's not ready. And he doesn't get ready because Aaron Donald lands on Andy Dalton's ankle in the second quarter. So either he's ready to play or not. And if he's not ready to play, don't throw him out there when he's not ready because it doesn't make any sense.
I need some Yak mix with that based on that tape.
I'm 100%
with
you. You know why? Because you talked about it. What are you hearing in between what they're saying? Is Justin Fields ready or not? This is not about Andy Dalton. Chicago fans know this is not about Andy Dalton. It's about when Justin Fields is ready.
Right.
So the minute he is, that's when you put him in the game.
Right.
It's not because, he's athletic, he can outrun defenders. If the offensive line isn't good, we're not talking about just 2021. We're talking about the next 10 years. Hopefully, if everything goes according to the...
I'm about to get the eye roll of all eye rolls. But hear me out, Kmart. Hear me out. If Andy Dalton gets hurt or struggles early in this game on Sunday night, the quarterback they should go to is Nick Foles. He's on the roster. Here's my question. Marcus, here's the question. Is Justin Fields ready to play or not? Because if Justin Fields is ready to play, he should be your...
Okay, hello everybody. How's everybody doing today? Hopefully everybody's doing good today. There we go. How's everybody today? I hope everybody is doing fantastic. Go. Perfect. Alright. Okay. Alright, we're back. We are back for a 6 o'clock Math 102. We're here to, well, do some more statistics. That's what we're here to do. Question mark, question mark. How was everybody's weekend? I hope everybody's weekend was good. I hope everybody's weekend was good. Let's see. Okay. Moment there, I'm like, I can't think. It was good. Yeah, mine's pretty good. I was watching some wrestling this weekend. I watched some AEW All Out. It's great. Really awesome. Naomi, it was really nice. You got all the unpacking done. Very nice, Naomi. I got a question for you, Naomi. Have you been able to keep up with all the work at least? I hope all the work you've been keeping up with. Let me know. I know you had a lot to do the past couple of weeks because of all the shuffling around. Yes? Okay, good. Alright, good. I want you to keep that up, okay? Definitely keep that up. I know it's a little tough, but look, I need you to try this right. Put your full force of effort, okay? We're gonna do this. Okay, you and me, Naomi, let's do this, okay? We're gonna get you to be a success. Get it done. I want you to do well, Naomi. Trust me on that. 100%. You know to ask me questions if you have questions. Even if there's a doubt in your mind, you come ask me a question, okay, Naomi? Get things finished, we get things done. Get it squared away. Okay, very good. I'm happy to hear that. Oh, I did have a drink here. Now I don't have a drink here, do I? Put my water in the fridge. Let me go grab that. Hang on a second. Do I know when? Yes. Yes, it's probably, now this is saying probably. Probably I will, announce when the test will be, probably next week. So, I don't have a problem with, don't worry, it won't be due next week, okay, Naomi? That's not what I'm saying. But, we'll probably finish up Chapter 3 by next week. So is my estimation. It could be sooner, but I wanna go slow, so been going a little slow. You have a question about Mymathlab? Sure, go ahead. Yeah, I totally understand. Totally understand, Naomi. I will. You know, when I make an announcement, I'll give you a week ahead of time worth of warning. So go ahead, and make me proud. If you got a question about Mymathlab, go ahead. More than happy to answer for you. How do I know if I purchased the book or the Mymathlab Access? Well, the access code is purchased. If you purchase the access code, Make Me Proud, you will get the electronic textbook to go along with that. So the e-text automatically comes with the access code, Make Me Proud. So online bookstore, so basically once you get the access code and you register for the course, then you just have to click on the e-text and you automatically get the e-text with the access code. Like, you don't have to buy them separately. Okay, unless you want a physical copy of the textbook, Make Me Proud, which is entirely your option. But if you don't want that, you just want the e-text, you automatically get it with the Mymathlab Access. Okay, I didn't think so. I'm like, usually I'm like, well, why do you need a physical copy of the textbook? Did you register already? Make me proud. Are you already set on Mymathlab? Have you registered yet? Make me proud, because you should have by now. Okay, then you have to buy the access code there. All right, so temporary access only is exactly as it sounds, temporary access, but that only lasts for 2 weeks. You need to buy the actual access code. All right, and the actual access code is like $80. So you actually have to buy the access code through Mymathlab, and you will get access to the electronic textbook. So yeah, be sure you have to, again, you want your homework to count and everything. I won't be able to see what you got for your scores, so with only temporary access, it'll then shut it down. But if you get full access, then I'll be able to see it, and I can give you credit for that. So Mymathlab, yeah, of course you can. Financial aid's pretty common with Mymathlab access code. The only thing that you have to do is go through the bookstore. So here's the thing, right? And I'll full disclosure for you, make me proud. You can buy the access code for $80, or if you go through the bookstore, it'll cost you like 120 or 130. You know, whatever. It's like a huge markup because the bookstore's going to overcharge for everything. So with financial aid, they'll cover the cost, right, for the access code, but then you'll end up owing like 40-50 bucks more than what the real cost is going to be through the website. So at the end of the day, it's your prerogative and it's your choice which way you want to go, but you need to sign up for it like ASAP. Like, you need to make a decision like probably this week, and you need to like register pretty much immediately at this point. So we're like in week number 3, and so you need to get on that, okay? All right. Okay. So if you've done assignments, all right, I'm not going to disapprove of you doing assignments. Trust me on that. What I'm concerned about is, will it count because you don't have a bought access code yet? That's what's making me worry. So I want to be sure that those assignments are things that I can see. That those are things that things don't get wiped out. Okay. So I want to be sure that things are on the up and up. Okay. Get that full access. Okay. Do you have any ad blockers on or anything, Strolling? You click on homework or assignments. Yeah, homework / assignments tab. If you have any ad blockers or pop-up blockers, then you want to turn those off and allow them for the for Mymathlab. And sometimes it shows, sometimes it has a little bit of a thing. Mm-hmm. Hang on a second. Okay. Hang on a moment. Even even I'm having issues right now. It says you can't open the course. Why? Why can't you open? Hey, what? Okay. That's really weird. I'm confused what that means. You're on D2L, Strolling. You're on the wrong part there. No, no, no. Strolling, you're on D2L, my dude. I'm talking about actually on Mymathlab, the actual website. If you want to find your assignments, my friend, they are all on Mymathlab. Like, you're trying to find the assignments, like what I pointed out the first day of class there, Strolling, is you need to go to the actual website of Mymathlab and you need to actually sign up. Guys, you guys gotta rewatch that video or whatever the case may be, because, again, you guys gotta get on this ASAP. Like, it's now week number 3. It's on Pearson. It's on the actual website, my man. Like, I'm gonna be perfectly honest with all of you. You can't delay signing up for this. If I say come around next week, we finish up chapter 3, and then the following week all the stuff is due. Like I said before, you wait till the last minute to get stuff done, it doesn't work out so well in your favor. So I'm just gonna give a word of warning here ahead of time. I don't want that to happen to you, okay? The only way you're gonna be a success is that you're making sure you get things squared away, you know, ASAP. That's how it's gonna be. Like, I'm not gonna sugarcoat it anymore, because there's no point in sugarcoating it. Like, this is what you should see. Like, I'll put this on the main screen here. Like, this is the screen you have to be here, and you click on homework, and then these are all the assignments for the homework right here. So get on top of that. That's very important. All right, we gotta get started here. Let's get going here. Let's do some stuff. All right, let's do it, ladies and gentlemen. All right. Okay, let's get started today. Welcome back to Tuesday. Hopefully a nice Labor Day weekend. All right, so today, ladies and gentlemen, today hopefully will be a little bit of a review for most of you for what we're going to be doing here today. And today we'll also be using the calculator a little bit extensively. So today, again, let's talk about last time we talked about misleading graphs. We talked about how to put stuff in a stem and leaf plot, histograms, the whole 9 yards. Today, ladies and gentlemen, we're going to be talking about our good friends mean, median, and mode. Now, most or all of you have heard of mean, median, and mode. This shouldn't come as a surprise to absolutely nobody, but we're going to see it in a slightly different light. So a slightly different light here compared to what we have talked about before. All right, so let's take a good look here at the big board, and you probably see already how this could be slightly different. All right, let's take a look at number 2. Number 2, which is from the last handout here. How do we find mean? All right, so mean here is going to be equal to the sum of all the data items divided by the number of data items. Now, this is something that we've all done before. Probably at some point you've talked about average or mean. They mean the same exact thing, okay, literally. All right, and all we do is we take all the numbers, right? We add all the numbers together, and then we divide by how many numbers we got. All right, that's all we do, right? That's all you generally do when you talk about mean at the end of the day. It's fairly straightforward. However, looking at an example, we'll look at an example here in a little bit, but what I want to more focus on here when it comes to mean is, although mean is an easy concept that you've probably done lots and lots of times, just finding the average of something, what I want to more focus on here is what you can see here on the screen is the notation behind mean. Okay, because a lot of times in statistics, we're going to be looking at a lot of different notation here that has different meanings. And you do need to get comfortable with this notation here, only because of the fact that you're going to see this in a lot of different parts of the textbook. And so we want to be sure that we get everything squared away in terms of what each of these notational guys mean, because, again, the book does use it liberally at the end of the day. All right, so let's take a good look here at the notation. Now, the notation here we have first is x bar. X bar is the sample mean. All right, now the sample mean, and we also have down here, by the way, is mu, which is the population mean. There's actually 2 different notations here for mean depending on the context. One is the sample mean, which is x bar, so you'll see that often. You also see this often here, which is mu, which represents population mean. They have 2 different meanings. This is true because they're 2 different perspectives or points of view. Whether you view your sample as a population or whether you view your sample as a sample. All right. Next, we have this this guy here, which is the sigma. The sigma here represents the words the sum of all. So notice the mean here is the sum of all data items, okay? Sigma here represents the sum of all. Now, what you're going to see me do quite often here in these handouts is I'm going to go ahead and write it in notation as well as write it in words. So I will be writing in words, and I'll also be writing it in notation, so that way you can get comfortable about what the meaning behind each one of them is. Okay. Okay. Next is xi. Xi represents a data item. So we're taking each individual number, each individual data item, and we're just adding them together. So the sum of all data items. And then little n here is the number of the data items in the sample, or the sample size, again. And capital N here, again, is the population size if you're looking at it from a population perspective or point of view. Okay, so let's go ahead and do an example here. Let's go ahead and do an example here of mean, and then we'll use that example here to do the next couple of questions as well. Let's go ahead and do that right now. Okay. Let's make a little bit of a stem and leaf plot here. Okay, and we'll take a look here at these numbers. So we have stem and leaves. All right, so we'll go 0, and we'll go 2 and 5. That. 2, 6, 7. 9. 1, 4, 8. 8. 2, 9. 5 and okay, there we go. All right. All right. Oh Lord, that's a terrible. That's a terrible joke, Dylan. That's a terrible joke. Oh my goodness. Ay ay ay. Oh jeez. All right. Anyway. I wonder how many Amis it takes to change a light bulb. Well, none. I'm too lazy to do. All right. So let's go ahead. Let's go ahead and take a look here at our example. This is a stem and leaf plot here. Now what we want to do here is to find the mean here. Now finding the mean here isn't too hard. All we got to do is take each one of these numbers here, add them up together, and be able to, determine what we get for our final result. We'll divide by how many numbers we got. Now again, just as a friendly reminder here we have 0, 2. This just represents the number 2. 0, 5. That just represents the number 5. 1 and 1 represents 11, 1 and 2, 12, and so on and so forth. So here we're just going to go ahead and add up all the numbers here together. All right, so we have 17, 23, another 23, 29, 31, 34, 38, 42, 49, and 53. Let's go ahead and see how many numbers we got. So what's our sample size, everybody? How many numbers do we have in this data set? How many numbers do we have in the data set? You can type it out in chat. All right, 16. 405. It's an interesting number to have, David. 405. I'm not sure how we came up with that, but okay. 16. Good. Oh, okay. I was gonna say, I'm like, hold up a second. How do we have 405 numbers? Oh, goodness. How did we get all these numbers? This is from the stem and leaf plot here. So each one of these stems represents the tens digit. Each one of these leaves represents the ones digit. So 1 and 1 would be 11, 1 and 2 would be 12, 1 and 6 would be 16, 1 and 7, 17, 2, 0, 20. You get the general idea. So 0, 2 would be 2, 0, 5 would be 5. So you add up all those numbers together there. All right, so we got, well, I'm assuming 405 divided by 16 here, if that's correct. That's deemed to be correct there. What do we get here as our mean? What do we get here? You guys tell me. What do we get here as our mean? Exactly 25.3? I want 4 decimal places, guys. 4 decimal places. Remember, that's going to be our standard MO here. 4 decimal places. So 25.3125. Yeah, we're not going to put to 1 here, guys. It's always 4 decimal places. So, make sure that's going to be your standard MO moving forward, all right? All right, so 25.3125, I can get behind that. All right, so that's the mean there. No problem. Pretty easy to see. Again, you could label this as X bar if you wanted to. Again, if you're looking at it as a mean, or you're looking at it as a population, you label it as mu. Whatever you want, depending on which context you work over. Okay, now that's not too hard. Pretty simple stuff. All right, let's put this on the half and half here. Hey, Yusuf, how you doing, my friend? My thoughts on Ellis with his chosen charity? Wonderful. I think Ellis is doing a wonderful job. I think it's a great thing. All right, let's look at number 3. Number 3 says, how do we find the median? How do we find the median here? Well, let's take a good look here. Now, median is something that pretty much everybody is pretty comfortable with. But again, let's talk about one of the most important things here when it comes to median. One of the most important things here is that we always order the data set before we find the median. So we have to put everything in numerical order. Now, if you take a look at the example that we are using here, this stem and leaf plot, everything is in numerical order. Okay, so again, I put all the numbers in order, okay, from least to most. Okay, that's basically what I've done here. All right, and then that's the first step that you have to undertake when you talk about the process here about finding a median. Okay, so that's the first thing that you have to do, regardless of whatever it may be. But if we're trying to find median here, that's the first thing that we must do. Now, once we've got all the numbers in order, let's talk about what we do next. Let's talk about step number 1. Step number 1 says find the position of the median. Okay, so we don't directly find the median. We have to find where the median is located. Okay, now everybody can say, well, the median is the middle number. And I could be like, yeah, you're correct. Actually, definitely you're right. It is the middle number. But the question really comes down to this is where the middle number is located. That's the thing that you have to actually focus on first. Again, this just removes all the guessing about where the middle of this data set is going to be. For an example like I have over here to my right, to your right here on the screen, This stem and leaf plot's pretty easy since there's a limited amount of numbers. But imagine, if you will, you had a data set that had 1,000 numbers or more. Well, then now you want to find that position, because it's a lot easier to find that position first before you go ahead and find the actual median. So I'm saying, if we want to be consistent with our process, this is the way we're going to go about doing it. So finding the position of the median first is that to find that position of the median, we're going to take the sample size here plus 1, n plus 1 divided by 2. All right? And basically based off of that here, in step number 2, is we're going to run into one of two scenarios. So we're going to have to find the median here based on one of two scenarios here. And that is dependent on the sample size that we're given here. So if n is odd, an odd number of, if our sample size is odd, then the median can be found exactly at the position that you find in step 1. However, if n is even, then the median is going to be found of the mean of the two numbers around that position found. Now you're probably saying, whoa, 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 time out. Slow down for a second. What exactly does that mean? All right. I'd be like, okay, that's fair. Let's go through the process for this example here, and let's see exactly what we come up with, okay? Let's go slow here. All right, so the first thing we're going to do here is step number 1. Let's go ahead and find the position of this median here first and foremost. It says me. All right, so the position of the median here, we know from before, you guys had said, hey, our sample size here is 16, right? You guys had clearly said we have 16 numbers in our data set. So that's fine. We'll take our 16 plus 1 divided by 2. So here we get 17 over 2, which then will net us 8.5. Okay. So the position, again, 8.5 is not the median. It's just where it's located, okay? So let's just understand that. It's exactly where it's located here, all right? So let's take a look at the 8.5 position here. So we'll mark it down with an arrow. So we'll count how many numbers we got. So we got 1, 2, 3, 4, 5, 6, 7, 8, 8.5. 8.5 would be right here. Okay? So 8.5 is right here, between these two numbers here. Now this one here is pretty easy in terms of finding the median, but just to showcase how this works, what you would need to do here is that realistically, there is no number in the 8.5 position, all right? There is absolutely no number in that position, okay? It makes no sense, right? An 8.5 position, 8.5 position makes no sense, but that's why we have this second guy here. Again, if n is even, then the median is going to be the mean of the two numbers around that position found. So no matter what those two numbers are, in this case, pretty simple because both of them are the same, but still, I'm going to do it out anyway. So we take that 23 plus that other 23. That's both of these 23s, by the way. This one and this one. Again, this one and this one. And then we divide that by 2. So here we get, of course, 23 as our median here. Case. All right. So that's how we can go ahead and find median here. First, find out where it's located, and then go through the process about actually finding it once you know where it's located and you know the position about where it's located. Any questions about that? Hopefully everybody's good with that so far. Oh, thanks. Variance is like, no, thank you. Okay, I heard you. Got it. How did you get to use 23? Because take a look, it's in the 8.5 position, so I counted 8.5 positions here. 1, 2, 3, 4, 5, 6, 7, 8. So that's where I put the arrow here, strolling. And then basically I take the mean of the two numbers around that arrow, which in this case both happen to be 23. Don't forget it's a stem and leaf plot here. So again, that's what this 2 outside represents is 20. Both of these leaves represent the 1s. This would be the 3. 23 and another 23. Like this 9 here would be 2 and 9, 29. Does that make sense? Any questions, strolling? Okay, cool. All right, cool. Any other questions before we move forward? All right. Nope, not indeed. All right, that's fine. Okay, let's talk about median just a little bit more here. Okay, now one thing in statistics is that median is a better indicator of a data set than mean. Now, you're probably saying we always talk about averages all the time. Averages usually are best for an indicator that's best used in many situations. In some situations, an average is excellent to use. In other situations, an average is probably one of the worst things to use. Okay, let's talk about why that is. So why is median better than mean in most circumstances? And we'll talk about this answer here. But let me throw you a scenario here that'll hopefully help you help make it a bit easier to kind of understand why this is the case. Why median in a lot of realistic circumstances is actually much better. Now, let's say, for example, here we had a neighborhood. Okay, let's say, love this example here, but let's say we had a neighborhood full of houses. Let's say there are 3 houses on this block. All right. Now, let's say we're looking at the valuation, the property value of each one of these houses on the block. So let's take the first house here. Now, let's say the first house here is super run down. It has rotting wood everywhere. It's a huge fixer-upper. It's barely put together with the nails that are in there. All right, but you could fix it up and make it look nice. So, of course, people are offering a rock-bottom price of $10,000. Okay, so it's a $10,000 house, all right, but it needs a lot of work, okay? Lots of TLC. Let's look at the next house. Now, the next house on the block is slightly a bit better than the first house. It's still got some rotting wood. It's got some boarded up windows. It needs a lot of work, but you know what? It slightly looks a little bit better than the first one. So, of course, then the property owners are offering it for $20,000. Okay. Now, let's say there's a third house on the block. Okay, so let's say there's a third house on the block here, and it's the brand new house compared to the other houses on the block. It's super shiny. It's got all the amenities, all the bells and whistles, everything under the sun. Let's say that one is worth $1 million. So it's the super fancy mansion of dreams. It's $1 million house. Yeah. Okay. Now here's the thing. The thing is that let's talk about average or mean. Now, if we took the average property value of the houses on the block, we would take $10,000 plus $20,000 plus $1 million. We'd divide it by 3 because that's how many houses are in this neighborhood. And you would say, well, the average property value for houses in this neighborhood would be $333,000 plus, some change. And then you'd be like, well, wait a second here. That's not true. It'd be worth, that's the average amount that the property values would be worth, but it's not true that a majority of the houses are worth $333,000. The first 2 houses are kind of run down and need a lot of work. They're not worth like $333,000. So you got a problem there, right? The $1 million house is skewing the average here by leaps and bounds, by a very large amount. Now, if I looked at the median, it's in numerical order in terms of the values of the houses. I looked at the median value of the house. Well, the median value here would be $20,000. That's the middle house. And this does accurately reflect the entirety of the neighborhood because 2 out of the 3 houses are worth close to that $20,000 that you see there. So the $20,000 is not affected by the $1 million house at the end of the block. All right, and that's incredibly important to look at if we're talking about larger data sets, our extreme values here. So if we take a look here at the answer here specifically, why is median better than mean is because median here is more resistant to extreme values than the mean. With the extreme values, you could easily do a survey or again do some kind of study, and you could have an extreme value that just is an anomaly that happens out of nowhere because it's just maybe this just happens to work out that way. All right, don't know why, but you know what, it happens. Okay, extreme values can certainly happen because it is what it is. So we want to actually look at the median here to get a better sense of the data set than rather having one value skew all the data in terms of one direction and ruining the study altogether. That's why when you talk about salaries and expectations, you should always look at expected salaries in terms of a median salary. So let's say, for example, you want to become a computer scientist. If you want to become a computer scientist, well then it's better to look at the median salary of an incoming, starting out computer scientist than a mean salary. Reason why is because again, if you look at an average salary, the average salary could reflect people who could be paid hundreds of thousands of dollars. Okay, you could be a senior computer scientist, and that may not be not even the position you want. But again, that doesn't properly reflect. If you've been paid $100,000, it's going to skew the average of what your expectations will be. What you really want to look at as a realistic expectation, you always look at the median salary, and then that will give you a good idea about what your salary expectation should be in that particular field. Like, you shouldn't over ask about how much money, otherwise they're going to not hire you because you'd be too expensive. To say, oh, you don't have any experience, why should you get $100,000? It doesn't make any sense. So that's something to keep in mind in regards to that. So hence why we look at median more than we look at mean in these cases. All right. Okay. Any questions about that before we move forward? No. All right. That's all right then. Okay. Let's take a good look here at the next one. Now, the next one here is pretty easy. I think most people will not have a hard time with that. Let's go split screen for this one too. Okay. The next one here talks about our good friend mode. Okay, how do we find mode? Now, mode here, let's talk about the definition here first and foremost. The mode is the data item or items that occur the most often in the data set. All right, now we do have some rules here associated with mode. Okay, so these are rules that we absolutely have to follow with mode. Number one, if we do have a mode here, the mode must occur more than once in the data set. So if it occurs, let's say that number occurs just one time in the data set. Well then, too bad, so sad, that number does not count as a mode. Okay, so that is a no-go. It has to occur at least 2 or more times in order to be considered as a mode. So that has to be requirement number 1. The second requirement is that as a fallout from that particular rule is that there can be multiple modes. It's certainly possible to have multiple modes. Again, as long as both numbers happen to occur the most times in the data set, okay. If we have 2 numbers that occur twice in the data set and that happens to be the most times in the data set, great, then we have 2 modes. That's what you call bimodal, for example. But on the flip side, based on that definition, based on that rule, it is also possible to be on the flip side here, we could have no mode as well. So maybe each number occurs one time, and guess what? There happens to be just no mode, and that can happen. Okay, it's entirely plausible just to have absolutely no mode, and it is what it is. All right, just based on the rules that we see here, because each number just occurs once, and there you go. So let's take a good look here at our example. So looking at our example here, if we take a look at this stem and leaf plot here, what is the mode of this data set that we have here? Anybody tell me, what is the mode of this data set? The mode here is 23. Oh, no, that's cool, Maritza. I know what you meant. 23 is correct. That is right. Okay, so 23, as we can see here, 23 occurs 2 times, all right, in the data set, and it's the only number that occurs 2 times in the data set. So therefore, 23 is going to be our mode. All right, very good. All right, so not too hard, fairly straightforward here. All right, next, let's go to the next question here. Okay. All right, so the next question here is by far and away, ladies and gentlemen, the most absolutely most boring question ever known to man. And the most boring question in this course is, how do we find the range? Well, you take the highest number, you subtract it by the lowest number, and then bada bing, bada boom, you got yourself a winner chicken dinner. It is extremely boring. It's extremely unexciting. All you gotta do is look at the highest number. What's the highest number? 53. What's the lowest number? It is 2. Yay. So 53 minus 2. So our range is 51. And yeah. There you go. That's all you gotta do. It's great. Folks, this is what you paid for. Alright. I'm just gonna leave it at that. This is what you paid for. Alright. I'm not even gonna ask you if you have any questions. This should be like super simple. High number minus low number. Oh my goodness. Yeah. Alright. Let's move on to bigger and better things. Alright. So, that's talking about our mean, median, mode, and range sort of guys there. Actually, before we move on, though, is there any questions about anything of those guys? Any questions? And then I'll move on to probably what's going to be taking up the rest of the time here today. So, no. Amy has the hand, back of the hand on the forehead. Be like, no. Be like, it's like, it's like every telenovela I've watched. No. Ah, que mi pobre. Okay, something like that. Oh my goodness. Ay, Dios mío. Be like, escúchame, por favor. Escúchame. And of course, you have to tell the whole story about like every single detail that's happened like the past 2 seasons, and that takes like 2 episodes to do. And it's unbelievable. It's like that's how you fill it in, folks. That's how you fill it in. All right. All right, take a look here at the next 3 questions. Okay. So let's talk about the next 3 questions. We'll come back to the example here shortly. But let's talk about the next 3 questions, because the next 3 questions on the handout is going to be something brand new. So I know that for a fact that everybody's seen mean, median, mode, at least in some capacity. But the next 3 questions is something that's new here, because this is more aligned to statistics, okay? This is more aligned to what the class is all about. Now, this is a topic that we're going to be talking about here because it has quite extensively, because of the fact that you do see this a lot in a lot of different concepts, okay? And that idea here is we talk about here. Let me zoom out for these Okay, there we go. That talks about specifically here, refers to population variance. So what is population variance? Sample variance, and more importantly, number 9, which discusses sample standard deviation and population standard deviation. Okay. Get to the other one, actually. Switch. All right. This one's the better one. All right. So first and foremost here, if we take a look at this in words, well, how do we find the population variance? Okay, let me zoom out. Yes, thank you. All right. Pretty bad. All right. Is that better? Okay, that's better. All right, so how do we find the population variance? Now, the population variance in words is basically the sum of the data item minus the population mean quantity squared divided by the population size. So again, in letters, what does this look like in letters? This looks like this rho squared is equal to the sigma, again, x minus mu quantity squared. Again, this mu represents population mean, capital N population size. All right, and mu squared here being the population variance. How do we find the sample variance? Again, sample variance is going to be, the notation here is s squared. We have sigma, okay, x minus x bar. And so we certainly have that. That shouldn't be too much of a problem here. Yeah, I can make it bigger. Is that better? Actually, right this. Hang on a second, guys. I'm trying to fit it all on the screen. It's just a little tough. There we go. Is that a bit better? There we go. I think that's actually, no, that's actually pretty bad. All right, look at it. Let's try it this way. There we go. Let's do it this way. I think that'll be fine. All right. Okay. Now, we take a look at these two definitions here regarding variance. All right. Now, one thing I do want to point out here for you guys, and one thing I do want to state here before we move forward, is that do you have to memorize these formulas? So, well, that's one of the questions I always get. Do you have to memorize these formulas? And the answer is no. You do not need to memorize these formulas. I would like you to apply them in some capacity, and we will see how to apply that in our capacity here. But we do not need to go ahead and actually memorize these in any which way. But it is important, though, to get to know what the notation is behind each of these. So the specific notation I would like you to get to know here is specifically going to be, again, the rho squared you see out here for population variance, and the s squared here for sample variance. These are going to be pretty vital and important for what we're going to be doing here later on. Okay, so I do want to point that out here, at least in this case. Why? Well, I want to specifically look at question number 9 here. So if you ask me to come back to 7 and 8, I will. All right, but I want to focus on question 9 here specifically because that's going to be the big one. Okay, so this is all question 9 here, and we're going to go through this together here carefully. So let's talk about how do we find the sample standard deviation / population standard deviation. Okay, though there are two separate things because two separate contexts. So the first thing that we have here is what is standard deviation? And this is a concept we're going to use a lot in this course, is using the idea of standard deviation. So standard deviation as a definition means is the average of how far away the data items are from the mean. So we just take a look at the average we look at the whole data set and we say, well, what's the average about how far away that they are from the mean? Well, we can actually go ahead and find that out. Now you can see the formulas here for sample standard deviation and also population standard deviation. There's one thing I want you to clue in on here. Okay, although they look very complex, let's compare for just a moment. Take a look at the notation here for sample standard deviation. Well, the notation here is S, right? You see S written here, and then you have the square root of all this stuff. This S here for sample standard deviation is exactly the same S that you have up here for sample variance. How do you get from S squared to S? Well, the way you get from S squared to S is by just simply taking the square root. So if you take the square root of this formula here that you had for sample variance, That's exactly what you have down here to find the sample standard deviation. That's why, again, why these two things link together. One is just a square root of the other. Population standard deviation works exactly the same way. You take the square root of, again, rho squared, and you get rho, and then there you go. Simple dimple. All right, like I said before, do I need you to memorize these formulas? The answer is no, but again, you do see the notation here. Again, calculator notation, we'll take a look at that momentarily, will be Sx or S sub x, or rho x or rho of x if we talk about population standard deviation. All right. Okay. Any questions so far? Hopefully, again, I know this looks a little confusing based on what you see here written on the screen. Again, but again, we're not getting into too much detail about how we're doing this by hand. If we were to do this by hand, it would take quite a while to do, but that's not what we're doing. So, but any questions so far about these two guys? All right. I'll assume that that's a no, because I do need to move forward. All right. Yeah, you can see those for a quick second here. I do have to move on because we got something important to do. So. Okay. So the next part here that I'm going to do is talk about how we can find sample standard deviation and population standard deviation. And so we're going to go ahead and use the data set that we have here from our example. Now, what I would like you to do right now is to take out your graphing calculator and make sure that it's in front of you. Okay, so again, take out your graphing calculator, make sure that it's in front of you. When you have your graphing calculator out, or if you already have it out, go ahead and type in done in the chat. Okay, I want everybody to be on the same page for what we're going to be doing here next, is finding it via the calculator. Please type done in the chat, so that way I want to be sure everybody here we're going to be doing it all together here. You take a minute here if you need to find that calculator there. If you already have it, type out, or once you have it or already have it, type done in the chat so I know that you have it ready to go. All right, I'm gonna go. All right, I'll give you guys another 30 seconds or so. Make sure we have everything set to go. Okay. I'm gonna go split screen here for this. Okay. Everybody okay? Anybody else having issues finding the calculator? Hopefully everybody's got it. I'll move on in about 10 seconds. All right, let's go ahead and move forward then. Okay, so I'm going to go through this carefully and slowly, okay? So I promise you I don't want to leave you behind, okay? So I'm not going to go super fast, all right? I'm going to do this one step at a time, all right? So the first thing that we're going to do here is I would like you to go ahead and hit the stat key here. The stat key here on your calculator is the thing my mouse is circling right here, right next to your arrow buttons. So please hit the stat key here, and you're going to get to this menu right here. And then the next thing I would like you to do is to see, if you notice, the first thing that's listed here is the word edit. Okay, I want you to go ahead and hit enter on the word edit. Okay, so you stat and edit and then hit enter. And so what you're going to see in front of you, if you do that, is you're going to see a set of lists. Now, if you have the new style calculator here, the newer software's calculator, you may see, like, I have the super fancy software here on my computer. admittingly. So I have 5 lists that show up here on screen. But if you have the old school calculator, you may only see 3 lists on your screen. In either case, you'll see some amount of lists on your screen here. So before we move forward here, I want to be sure everybody is on this page here, okay? And make sure everybody is on point. So please type done in the chat once you have reached this this menu, this list page here. Remember, if you're having trouble, please, I will explain it again, okay? Let me know. Everybody okay? Is anybody having issues? What do you mean it's the calculator? Tell me. What do you mean by that? That's fine if it shows data. It's fine if it's showing data. That's not a big issue. We can take care of that. I haven't gotten to that point, but yeah. If it shows data like I have data on my screen, right? You can see there's a list of numbers there, right? Right, Sanala? So if you see a list of data, that's fine. We're gonna take care of that right now. So if you do see some numbers here, because again, for some of you these calculators could be hand-me-downs, they could be rented, they could be whatever. Okay, if you see data here, like I have on my screen, what you want to do is remove that data. In order to remove that data, what you want to do is you want to highlight the list here, hit the up arrow until you highlight the list, okay? And then I want you to hit the clear key and the enter key, okay? So I want to put this here. Do not press the delete key. Hit the clear key and hit enter, and then that will clear out your data, okay? So that will clear out your list of data just like so. Remember, clear key and enter. All right. Sanla, did that take care of all your issues there, hopefully? Hopefully that data is now gone. You can do that for multiple lists, by the way, by just highlighting the next list over and then clearing out that data if you like. Sure. Not a problem. Make me proud. Let's go through this carefully. Again, highlight the list here. You're not highlighting multiple items here, Sanla, so follow me carefully here. Alright, so let me put in some data here real quick. You're going to highlight the list, just like so. Alright, so watch my screen here. Highlight the list. That's what you're doing. You're just hitting the up arrow, and you're just highlighting that list. Notice that it's blacked out here as the top of the list. Hit the clear key and hit enter. And then that will clear out the list. That's all you're doing. Column 1 has years. You're like 1980 something or whatever. Like I said, this is all you got to do. If you're in list number 1 here, again, just highlight the list, hit clear, and then hit enter. That's it. That's all you got to do. Don't make this super complicated, I promise you. So start over with me, Sanla, okay? Start over with me. Hit the stat key, the stat key. Go to edit. That's that very first option there. Just like so. Okay. And then you're going to go ahead and... yeah, you got to have the black bar be at the very top where it says L1, or whatever you want to call it. So notice that on my screen, that it's... Notice that L1 is blacked out like so. So it should look just like this so far before you hit... And then once it is, you have to hit clear and enter after that. You have to do it separately, Sanla. So you have to go to the next list and you have to do it separately. So you go to the next list, hit clear and enter. It doesn't do it for the whole thing. That's not how it works. You have to do it for every separate independent list. So you're trying to clear out all the lists all at once. It won't. The calculator won't let you do that. Okay, I want you to try one more thing with me, Sanla, okay? Try one more thing with me, okay? Do me a solid. That's fine, I know how to work around this. No, that's fine. I can show you. This is actually good if you want to reset. Hit the second key and hit the plus key. So I want you to hit the second key and the plus key, Sanla. Hit the second key and the plus key, you'll get to this menu here, the memory menu. And then go down to number 7, which says reset. And you'll get to this menu here. And then I want you to go ahead and hit enter on number 1, all RAM. Yep, all RAM. And then that will hard reset your calculator. Just hit say yes, you want to reset number 2. And then that will clear out, that should clear out everything. Now try it again. Now go back to stat, and then go to edit. And now you should have empty lists. That's a super hard reset, but it should work. Alright. Alright, we got it. Let's move on. Alright, next. What I would like you to do here next is to go ahead and let's enter in all the numbers in our data set here underneath list number 1. Now that we got Sanla on board, we are good to go. Everyone, like I said, I want everybody to be on the same page. So you're here to learn. We're here to. I don't want you to have to watch a replay because you know your calculator is being a dork. So all right. So we're gonna put in every number in here into our list number 1. Okay. Every number in here. So again, you should have 16 numbers. Again, that's what we said how many numbers were in the data set here. Once you have all the numbers from the data set here, from what you see on screen, into the list, please type done in the chat, and we'll move on to the next step. Okay. Okay. Make sure you didn't if you have 17 you should have 16 numbers here. So the last number should be with 16. So make sure you didn't add an extra number in there. Make me proud. Yeah, try. Just take a look and see which number that you have to do again. Start over again if you don't feel confident. So just go to the top there, highlight the list, hit clear and enter, and start over again. Then type in done once you have all 16 numbers, okay? Yeah, you should not have 17 numbers. Make sure to go slow, okay? Let me know when you got it. Make me proud. We'll move on. Okay. Yeah, sure. There you go. Again, you could also take a look here on the numbers on the right. These are all the numbers you see here, my friend. Let me know once you got it there. Hello? Okay, guys. You got to do it again. If you have 17 numbers, okay? You got to highlight the list, hit clear, and hit enter. All right? So make me proud. Look at all the numbers here on the right. These are all the numbers. So we got... All right, so again, clear the list out, strolling. You have to clear the list out. Again, highlight the list. Guys, this isn't too hard, I promise you. Highlight the list, hit clear, and hit enter. Okay? If you want to clear out your list and try again. So we hit 2, we have 5, we have 11, we have 12, 16, 17, 20, 23, 23, 29, 31, 34, 38, 42, 49, and 53. So it should be just in that numerical order there, all right? So again, at the end, you should have 16 numbers, okay? The cursor here will say 17, but you don't have anything in that 17th spot. So you have 16 numbers right there. So that very last one here, 53, should be in the 16th spot. All right. Once you guys got that down, we'll move on to the next step here, because we got to get this stuff down, guys. Done? Okay. Strolling, you got it? Got to get this stuff down, because you need to know how to use this calculator. That's the first thing. Well, I know I'm going really slow, guys, but if we don't understand how to use the calculator, well, then this whole class is going to be downhill from here. That's the last thing I want to have happen. So we want to get things down ASAP. Okay, good. All right. Now that we got that squared away, let's move on to the next step. Now, here's one thing that I do like to do, and this is just because of exactly as what has just happened here, is that we want to avoid entering in anything bad into our lists, okay? One of the things that is absolutely true is that the calculator is very particular about how it wants things entered in. So we want to avoid that as much as possible. So good practice to have on the calculator here is to quit to the main screen. To do that, we're going to hit the second key and we're going to hit the mode key to go to the main screen. So you should be back to our blank main screen here, just like so. All right. Again, this just makes sure that the list is saved in the calculator and that we'll be able to use it appropriately and we don't enter in anything bad. All right. So second in mode here. Again, that's going to be our next guy to quit to the main screen. Now, after that, let's go ahead and talk about what's coming here. So the next thing that we want to do here is we want to actually get to our actual final result here. So what I would like you to do is hit the stat key once again. But this time, I want you to go to the calc submenu. Hit the right arrow, and you'll get to the calc submenu just like so. Okay? I want to be sure everybody... Is everybody here at this calc submenu? Hopefully everybody is. Okay. Good, good, good. So stat, hit the right arrow key, and then you'll be in this calc submenu just like so. Okay, now we are going to there's of course a reason why we're in this little menu here, because we definitely are going to use one of these options, and the option that we're going to use here is 1 var stats. So that's the first option you see there at the very top of the screen. We're going to go ahead and hit enter here on number 1. All right, and so this is where things can easily deviate. So I do want to be specific about what's going on here. So take a look at this, what we have here. Now, some of you may see on the top, may see this on your screen like I have on my screen, this little sub-menu here for 1 var stats. And some of you may have the old school calculator where it goes to the main screen and you will just see 1 var stats at the top of your screen with nothing else next to it. How many people have the old? How many people do not? Tell me. All right, type in me in the chat if you do not see this submenu like I have on my screen. Please type me in the chat if you have the old school calculator where you do not see this on your screen. Yeah, if you have the old school, that's fine. I do want to state something here. Okay, so some of you have the old school calculator. Like my calculator is like my actual like TI-84 I found in a random classroom like many years ago. Is super old. This calculator is super old. Okay, this is super old school calculator. Even at 84 plus, this has older software in it. Calculator's gone through different software. Now, if you do have an old school calculator, one thing I'm going to tell you right away is I am going to go through both types. So on my screen, I have the super new fancy software stuff, okay? But if you don't have that on the super fancy software stuff, that's not a problem. I always go through both. So I'm going to go through, of course, the one that you see here on the screen, and also the old school way of doing it, because I know some of you have that old school calculator thing as well. Okay, so I'm going to go through both here carefully, so that way you know what button presses to also do, because all you see on the screen is just 1 var stats at the top of the screen, and you'd have nothing else. You're not really given a guide about what to do. So I will mention both here because I know for a fact that it can be frustrating when you're not given any guidance, unlike this submenu here. Now, I'll go over the new style calculator, and then I'll go over the old school calculator after that, and hopefully we'll end up the same result regardless. All right, so with the new style calculator here with 1 var stats, what you will see on the screen is something akin to this. You'll see list and frequency list and calculate. Now, what you want to do here specifically is you want to actually call upon your list here. This will default to L1, but if you want to if you don't see anything here, or again you accidentally let's say delete it out for whatever reason, you can get this list back here by hitting the second key and the 1 key. Okay, that'll bring up list number 1, okay, L1. All right, and then you can go down to calculate and hit enter. All right, and you're going to get a screen that looks like this. This is if you have the new school calculator, all right? Now, if you have the old style calculator, let me show you what you see on screen. The old school calculator is going to look something like this. You just have this. You just have one var stats that shows up on your calculator. But you need to call upon the list that it's going to test that over. So what you need to do is call upon list number 1, which is what our list of numbers is under. We're going to hit second and L1, and then second and 1 to bring up L1 here on the screen, and then you go ahead and hit enter. Okay, and then this is what you should see here on your calculator, just like so. So let me put that in the chat here. The 1 var stats L1. Okay. Now, please type in done in the chat if you have all these exact numbers that show up on your calculator. Please type done in the chat if you have these exact numbers here that show up on your calculator. All right, good, good. Yeah, you need to change your list there, Strolling. Your end here should be 16, but... Okay, well, that's good then. Okay, now let's take a look here at our results here on our calculator, and you'll see exactly what we've set out to do. Take a look at the very top. Notice we have X bar here, which is the mean of 25.3125, which is exactly what we got here at the very beginning of class here from just doing the mean out and adding up and dividing. Now, the other couple things that we can look at here, we did talk about the median here. The median here was 23. Notice that there's an arrow here off to the left. You can hit the down arrow here and actually scroll down. And you can actually see that we have a MED, which represents median, is indeed going to be 23. So that definitely tells us, yes, okay, that's 23. Easy peasy lemon squeezy. All right. Now, the other two things that we want to specifically look at is going to be the sample and population standard deviation. All right. Those are the specific things that we want to look at here. Bear with me for a few more minutes, guys. I know we're running a bit over time, but it's important we get this down, okay? So the sample standard deviation here is this SX you see here. So as you see here, SX represents sample standard deviation, and that's going to be the 15.1028. So we're going to write that down, 15.1028. And we have this rho X here. Again, that's going to be our population standard deviation here of 14.6233. Okay, so we're going to write that down here as our sample and population standard deviations. Now, we also did talk about variance here as well. How would we find variance? Well, sample variance here is not very difficult. All we have to do for, say, sample variance is we take the sample standard deviation and we just square it. Now, in this case, I'm not taking the rounded value. I'm going to take the full decimal value here. And I'm going to go ahead and square it. And we're going to see what we get here. And then we'll do the same thing here for population variance as well. And we'll just paraphrase here since I'm out of time. But I'll take the full decimal here. So 623 to 6379. And we're going to square it. So we're going to get two answers here for the variance as well. So let's go ahead and see what we get. We're going to take, let's do the first one here. 15.1028419. We'll square it. And so here we get for our sample variance is 228.0958. And then for our population variance, 14.6. Come on with the 4 today. I don't know. All right, 14.62326379. We'll square that. And here we get a sample variance of 213.8398. Okay. So there we go. We have our standard deviations. We have our variance. We have it all down. You're set and ready to go. All right. Very good. So hopefully you got comfortable here with the calculator and whatnot. That was one of the big goals here for today, is to making sure that you guys got that down and knowing how to actually use it here. Again, it can be particular here, and if you had a little bit of trouble, make sure to try it from the video again, and hopefully you'll be able to get it down, you getting these exact numbers that you see up here. All right. Now for next time here, we're going to go ahead and we'll finish up what we're doing here. Nummify says ask the question. Go ahead. So we'll go ahead and finish up this section here for next time. That's what the goal is going to be. But thank you for being very patient with me here today. Hopefully you guys, if you have any questions about the calculator, please feel free to ask, and I'll be more than happy to guide you through it one more time. Okay? I will go. Notice we're going slow over this, so that way you can get more comfortable. Again, I know calculators can be confusing for advanced functions. Hence why we're just taking it slow here. We'll be taking it slow here for a lot of different concepts, so we at least know what those button presses need to be, you know. Look, that's not a big look. In all honesty, Sunlight, it's not a big deal. You know what would slow you down more? It would slow you down more if you had no idea what you were doing. So I would rather have you be in a position. I would rather have you be in a position than that. So when it's sigma squared, do I take it to the power of 2 or multiply the total by 2? If it's sigma to the power of 2, then it'd be sigma squared. So you square it. If it's to the power of 2. I think I get rho and sigma always mixed up in my head. But I guess that's just me. As long as you understand the notation. The notation here means everything, so. Depends how it's written there, Numbify. Because if it's like times 2, if that 2 is like 2 sigma, 2 times sigma, then you'd multiply by 2. So give me the context here, Numbify. Would it be referencing a variance? Is that what your question is? Is that what your professor's saying? Like it's sigma squared? Is he talking about variance at that point? Because if he's talking about that context of variance, then it's going to be squared. He just may write it really different, but then he's talking about squared. I just would need to know the context, that's all. And then I could give you like a more definitive answer. But that's why I ask. All right. Well, while Numbify comes up with an answer here, which is fine. Take his time. All right. In the meantime, everybody, I want to thank everybody here for coming on out here to the chat. Once again, thank you very much. I think that would be squared. I think. Because it could be written like this. Like, it could be written like this, like 2... Like, let me show it on screen here. Hang on. Like, there's 2 ways to write this, right? So there's 2 sigma x, whatever x is. To me, that's 2 times sigma of x. Or it has to be written this way. It'd be sigma x quantity squared on top like that. If it's written like that, then that's fine. If he's writing it via text, then I would assume that to be squared because the 2's in front. The 2's not in front. The 2's on the right, not on the left. So if I were to say this is 2 times, then that has to be on the left. If I was to say 2 on the right and you're just writing it in like a chat box like we have here, then I would assume it to be this. If that's his intention. If you're not sure, just ask him again. But that's the way I kind of see it. Or you can have him, or again, you can have him say, if you could have him say in the chat, you could say, hey, can you write it like this? If you're having him in a chat box, tell him to write it with a caret and a 2. And then be like, okay, now I know you mean like it's going to be, it's squared. Because if he's shorthanding it and it's being too confusing because it's too ambiguous, then have him be more specific about it, okay? But I assume it to be squared because that 2 is on the right. So, but I don't want to be telling you, oh, this is the way it is. I want you to just ask him and say, put a caret there if you're going to be, if you want to be double extra sure. That never hurts. All right. Well, as always, again, thank you for the question, Numbify. Hopefully you get that cleared up. We could talk after class there, Strolling. Are you on Discord there? I'll talk to you after class. That's the invite to my Discord channel there, so you can we can talk in private, so we can see what's going on. Okay. Because I don't want to talk about your password on stream. So, all right, everybody, thank you so much for coming on the stream. You guys are absolutely wonderful. Strolling, we're going to talk after class here. We'll get things squared away. And as always, we'll come back in a couple days. We'll do it again. All right, everybody, thank you so very much. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right, have a great one, everybody. Thank you so much. Bring your calculators back for next time. We're going to be using them again in some capacity, I promise you. Thank you, Sammy. Thank you. All right, I hope you all have an absolutely wonderful night. All right, rest, relax, and take care of yourselves, everybody. We'll see you all later. Have a great one, everyone. Take it easy. All right, everybody. Take care. Bye. Bye, everybody. We'll see you later.